Right, Irene, she'll introduce our next guest. I think it's important that we have someone from the naturopathic that's willing to look at the science. There's more research that needs to happen. You can use things for a lot of things, we just need to be informed. And I'll tell you the one thing that you will see that I will get all animated about, and that is whenever government mandates anything. If they have to mandate something, I already know it's bad, because they have to mandate it. So that's kind of where my, fail-safe is right there. All right, our next guest.
How's everybody enjoying the day so far? Did everybody get to invite a friend that showed up? Oh man, I did. That's right, I did. So our next guest is also someone that I met through the social media venue of relationships that we, partake in, and has turned out to be a friend and someone that I count on for reaching out for information. Along with his latest book and a previous book that he has released, he was the former director of the bioinformatics core at the University of Pittsburgh for 6 years. That's a mouthful. And faculty department pathology and biomedical informatics for 7 years before that. So suffice it to say that James Lyons Weiler has spent his time doing work that most of us can't even imagine, right? So we don't delve into this arena of information. But what he's done that is so precious to me is that he's extrapolated information and made it available to us, for us to get the knowledge and be able to be informed and have a sense of stability with this information, and his books lay it out beautifully. So James Lyons Weiler, oh my God, Jack Knight.
Okay, thank you very much. When it's time to advance the slide, I'm just going to use a hand motion, Christine, right? I have a lot of slides, there's a lot of information. I want to take a poll of the audience and try to get to know you a little bit. It's how I teach my classes when I teach a course. Raise your hand if you're a parent who has not yet decided one way or the other if you're going to vaccinate or continue to vaccinate, if you care to share. Don't feel on the spot. Raise your hand if you're a parent who vaccinates. Okay. Raise your hand if you're part of the medical community, one way or the other. Okay. Raise your hand if you're a lawmaker. Okay. Raise your hand if you have a vaccinated your child. Okay. Well, now keep them up, and look around the room. You guys dominate this room, and that's what we see over and over and over and over throughout the country when we go on speaking tours. So, what you learned a great deal today already, and I'm not going to recap very much, but I do want to point out that you were told that the government is infringing on your rights, making plans to infringe on your rights as adults. They have been infringing on your rights to make decisions on behalf of your children. The AMA allows medical doctors, they have it in their statements, to have a personal belief exemption at the same time that the AAP is telling everyone, all the states, that they need to get rid of them for patients. We, the people, deserve equal protection, right? Why should medical doctors have the right to say, I don't believe these vaccines are right for me, but at the same time force them on the rest of the population? Let's see. I want to reveal I have 2 sons. They're both fully vaccinated up to HPV. I've done my homework as a deeply researched scientist on HPV. I wouldn't give it to my worst enemy. You can find my blog, jameslyonsweiler.com. It's incomplete immunization. It's not vaccination. There's 100 types of HPV out there that will replace the ones that are cleared by the vaccine, and they're rare for a reason. They're rare because many of them are more deadly. But let's get on with the talk. So, I wrote a book on Ebola, and then I wrote a book called Cures versus Profits. That tension, right? I live in that world. Do we get the best medical treatments, or do we get the most profitable medical treatments? I think some of you know the answer to that, but I basically fell down a rabbit hole in terms of discovering vaccines because I wanted to explore the biomedical successes around vaccines from a scientific perspective. I didn't have an agenda, I don't have a vaccine in your child or anything like that. And what I found with Dr. William Thompson, you were told by Marcy a little bit about that, was deplorable. It really, really annoyed me that they did to science what they did. So if anything, I'm a defender of objectivity in science, okay? So I created a research institute, my own research institute called the Institute for Pure and Applied Knowledge, and we do science, we publish papers, regardless of what we find, whether it's going to cost somebody money, whether it's not going to cost somebody money, whether they're going to make money or not going to make money. I'm a purist, I'm called a purist. We go to the next slide. Okay, so, the rates of autism are increasing. The question that came to me in looking at vaccines was, if vaccines could contribute to autism, how would they go? Well, they've done association studies, and I'll tell you a little bit about those. But how would it occur from a mechanistic standpoint, as a geneticist, as a biologist, how could vaccines induce autism? When I looked at that question. These rates are deplorable. They're 1 in 68, and the projections are, terrifying. That we're going to have 1 in 30, 1 in 25, 1 in 10, 1 in 2. The study that, next slide, some people say, well, it's just better diagnosis, right? We've heard this for a couple of years, right? But this is a study I referred you to, and the reference is in my book on the environmental and genetic causes of autism. The study that actually looked at it said that you can't explain that increment, that, that curve is not exponential. It has a curvilinear aspect to it. That cannot be explained by improvement in diagnosis. But instead, Dr. Nevison identified PDEs, glyphosate, and aluminum adjuvants in vaccines. So we're all exposed to these things. Well, that's general knowledge now, okay? But we're going to get really deep in the details of what that means. Go ahead to the next slide. If we're going to make an argument about causality, right, and Marcy did a good job of presaging this part of my talk, association is only ever causation. And it doesn't matter whether you're looking at vaccines, or if you're looking at genetics, or if you're looking at anything. If you just see an association, and it's only a correlation, it's difficult to assess causality, but it's not impossible. Sometimes correlation does support causation, and there are these flags that they wave. Correlation does not imply causation. But it's kind of hard to have causation without correlation, isn't it? Yeah. So if you think about it logically, and somehow our brains kind of turn off when it comes to autism, I think it's because it's about children, it's scary, they look normal. I've heard people say that. They're just acting differently. It's behavioral, it's psychological. No, it's medical, right? So if you have a child and they're playing in traffic and they get hit by a car, there's a correlation. You don't have to, and that's not meant to be funny. I said this to the Allegheny County Board of Health. When you say to the parents, they have medical people from the medical community show up and say, don't blame the vaccines for the adverse events from vaccines, basically, but when you eyewitness something, the way that these parents do, and they see it happen overnight, you've got a 3-year-old child riding a tricycle, talking, playing, inviting friends over, being social, and then they get vaccinated, and all that's gone. What's the difference between that and watching a kid play in traffic and get hit? You saw it happen. So that's a valid observation. And what I say to that is all science begins with observations. We've had enough observational data here. We've got millions of cases of regressive autism. If we're going to talk about mechanism, let me tell you what happened to the question of mechanism. When Congress told the CDC and the biomedical community to consider the totality of the evidence, okay, after the Andy Wakefield's study came out, and was supposedly debunked. Look at the totality of the evidence. They decided to do the weakest kind of science available. They did association studies, which are easy to cook. You can analyze the data 100 different ways and pick the one you want, which is what they did with the DeStefano et al. Study, and what they did with the Madison study, and what they did with 5 other studies that they hold up, okay? The IOM was brought in by the CDC, that's the Institutes of Medicine, or the National Academy of Sciences, brought in by the CDC specifically to consider the totality of the evidence, because they're the scientists, right? They looked at association studies, and they found 17 out of 22 studies were fatally flawed. So when you hear there's no association, there's no evidence. There's not a shred of evidence. Don't change the slide yet, but I have another slide coming up. Is because 17 out of 22 of those studies were flawed, and then 5 of them were potentially fraudulent because they analyzed time and time and time again. Believe me, I did data analysis just like this for a living at the University of Pittsburgh. If I ever took a data set and I analyzed it one way, and then decided the next day to change it and analyze it another way, I have to publish both results or I'm cheating. Believe me, okay? They did that time and time again. They would find an association, a very strong association, to the point where there's an email from Dr. Verstraeten to the CDC saying, it just won't go away. What do you think it is? It is the association. And they're like, no, go analyze it again. And you go to the publication, there's no association. Where did it go? You have to show all your work. It's basic third-grade math rules here, okay? If you're going to talk causality, there's a whole philosophy of books written on assessing causality in science. Let's just call it there's multiple levels of evidence, okay? I'll mark that with you there. For me, the ultimate that we can do for the question of autism is to be able to predict which kids will get autism from specific exposures. We're going to get into that. That's predictive clinical utility. Go ahead. So when you hear this lack of evidence, when you see there's not a shred of evidence, they took no evidence. The IOM told them there's no evidence because there's no studies. This one hasn't been studied. That question hasn't been studied. There's insufficient studies here. They transmogrified that into there's no evidence. Okay? And the summaries of the IOM reports made by some of the IOM people and the CDC don't read like the reports. Get a hold of those IOM reports. You won't believe what the IOM told the CDC to pay attention to that the CDC ignored. It's not in the summaries, but it's in the reports and they're available online. And whether the absence of evidence may or may not be considered the evidence of absence, you've heard this, absence of evidence may not be used as evidence of absence, is not the same as evidence of absence. It really depends on whether the studies have been conducted and whether or not they're valid. Next slide. So let me break down for you when you hear there's no association. These are things you can repeat and you can argue when people want to, say there's not a shred of evidence. They're arguing from a position of ignorance, the weakest position possible. You can get no association in the study, as Marcy told you, by having too few samples in your study. Small sample size, right? If you have something that happens, let me give you an example. Something that happens 1 out of 100 times and you have 3 versus 3, you're never going to see it. You can do that study 100 times, you're still never going to see it. You have a third and a third. You just don't have the power to detect. That's what that's called. The number one concern over the CDC studies that they cite and that they put forward saying there's no association is low power. No association after we analyzed it 100 times and made it go away. No association after we just excised the result from the PowerPoint presentation. Dr. William Thompson had a PowerPoint presentation with the result from the MMR in black kids, black boys, African American boys. Frank DiStefano took it out. That's a smoking gun. Congress has this. This is a matter of congressional record, thanks to Bill Posey. You want to get the files, they're available, show them to your friend. Here the result is shown, here it's not. No justification for taking it out except for they didn't believe the result, which is not science. You can't just say, well, we did all these subgroup analysis and we didn't find association of most of them, we found it here, but I don't believe it, so sweep it under the rug. The other reason, and this is an important one, no, autism is rare. It's relatively rare, but it's increasing. 1 in 68. It's not even 2%. You're doing this, the study design, the association studies were designed to detect a universal event that could happen to anybody, right? Vaccines do not cause autism in everyone. That's obvious, right? So we're falling for this hook, line, and sinker, black and white. Is it yes or no, yes or no, yes or no? Show me one kid where vaccines cause autism, one time you win the argument on the yes, no. I want to know frequencies. I want to know plausibility. I want to go into mechanism. Stop asking the question yes or no. Okay? What we got to say is, can vaccines cause autism in some people? If you do the study design for association type analysis where you just have a small percentage, it's not what the CDC did, so the science has not even been done. All of the studies they put forward were never designed in the appropriate way to detect a rare event. They're all junk. Next slide. Here's the CDC schedule, modified by me. The CDC says vaccines do not cause autism. The black are the vaccines where there's no science. Literally, not even just bad science, there's no studies. So how can you say vaccines, with an S, vaccines don't cause autism when they haven't even done the science? They did the science on the MMR, called Science and MMR. These slides are available, as you know. I think they just rely on magic. Honestly, they just make it up. Okay, well, it didn't happen with this vaccine, maybe it's not happening with that vaccine. That's dangerous, okay? These are our kids and our kids' minds. And the red ones are the vaccines where the science has shown that there's association. There's dozen or so studies that show association with certain vaccines. Hepatitis B, okay? You've heard about that. Why would you give this child a vaccine that's not going to work? And anyway, the titers aren't going to be there 5 years later, and it's a sexually transmitted disease that you can get from, prostitutes and from sharing needles during drug use. It makes no sense that hepatitis B would be given on the first and second day. They're taking advantage of young parents who are sitting there trying to do the best by their first baby. Okay? But there's a study that shows that it's associated with autism. Don't believe it. You're just being lied to. Next slide. So let's look. There is evidence of genetic risk. You're going to hear, listen, okay, fine. If you're not going to accept the association, we'll just make it genetic. It's all genetic, right? But the difference, there's definitely a genetic component to autism risk, no doubt about it. Autistics have a higher degree of what are called copy number variations. And excuse me if you're offended by my use of the term autistics, I don't mean anything by it. Please forgive me on that. I wrote a book of 150,000 pages, and I'm not going to say children with autism. Okay, I love your children just as much as you do, believe me. I'm just going to use shorthand autistics. So autistics have higher numbers of copy number variation than neurotypicals. Okay, they have a higher number of structural mutations than neurotypicals, and of the de novo mutations, the new mutations that are found that are not present in the parents, they're loss of function mutations. There's no doubt that there's some genetic component to breaking a protein and say breaking a synaptic protein and having a dysfunctional synapse. There's no doubt about it. There's a component of it. But the concordance estimates and the heritability estimates are all over the place. So the small studies that show the degree of inheritance as a geneticist, I'm going to reactivate your high school education. I've got 2 words I'm going to say to you. Everything you remember about genetics is going to come back. Gregor Mendel. Okay? P's. Okay? Remember all that? Okay. So the heritability of a trait is the rate at which the trait is transmitted with high fidelity from one generation to the next. And the concordance is just the agreement between 2 generations. The concordance estimates go from 0 to 100%. I mean, it depends on the study and the family. And the estimates of heritability are reasonably high, from 64 to 92, next slide. But we can't assess all of the inherited traits when it comes to things like behavior and language ability and intellect, right, to genetics, because there's a common environment. Right? If you look at siblings, that's the sibling versus sibling correlations. That's, the concordance. The inherited variation, we all speak with the same accents more or less as our parents. We have the same limited vocabulary as many of our parents, whatever. There's cultural things that we're exposed to. There's environmental things that we're all commonly exposed to in our homes. We share those. So we should more properly discuss genetic risk as familial risk. And then when you point to a gene and say this gene has been inherited, or this variation has been inherited from generation 1 to generation 2, then it's genetic. So when I say, oh, don't worry, it's all genetic, you say, well, actually, it's kind of more like familial, because some of that, what you think might be genetic, might be environmental. There's more to this. Next slide. Okay, so this is a typical pedigree. A pedigree is a pattern of inheritance. The yellow squares are the boys with autism. If it's genetic, how come the parents don't have autism? Okay? This looks like to me that our population of humans are dipping our toes in toxic soup. Right? And their children are reflecting that because their body size is small and they're more susceptible and they're developing. We're already developed. If you expose me to toxins that you're exposing to a 3-month-old, I'm going to have a minor response in terms of the scale of the response of a child, of a baby. And also, within this one family, the variation in the autistic traits was huge. Okay, so if it's genetic, then the autism should be like, clones of it. Next slide, please. I'm going to introduce you to a term that you can use. It's called G by E. Is it genetic? Is it environment? Or is it a genetic environment interaction? Okay? I'm going to give you lots of examples of that. So, yes, there's high concordance between generations in terms of ASD traits. have a higher prevalence of autistic-like traits. There's also a positive expression between the penetrance, that is, the number of people in a family that have the trait, or autistic-like trait, and the expressivity, the severity of the trait. These are all support for genetics, a genetic component. I tell you, I'm objective. I'm going to tell you what I see. And in families that have many more people with autistic kids, okay, many more autistic kids, the degree of severity of the autism seems higher there too, which means that we have multiple hits. Go ahead, next slide. And G by E, the genetic by environment interaction, can be simple or it can be complex. It can be simple, like say, okay, maybe there's a gene that makes MSG very, very toxic to your family. I get migraines when I eat MSG, okay? It could be complex in very, very complex ways that I won't go into, but it can be complex like maternal infection, can bring about social deficits in communication, but only if that child has no cognitive and adaptive functioning. So it can be very specific and complex and conditional, but it's still G by E, which means that it's not genetic. It's the gene's influence and interpreted in the context of an environment. Next slide. You'll hear, well, maybe it's just aging parents. You know, the demographics are that people are waiting to have kids and it's aging parents. And yes, there is a relative risk that increases if you're an older guy, these are dads, in having an autistic child. But what changes the man from the age of 21 to 50 but the environment? Right? It's mutations in the sperm. So if we live in a highly mutagenic environment because there's Fukushima blew up and you live in California, possibly you're going to end up having mutations in your sperm you wouldn't have had at the age of 25. That's environmental. Next slide. So I don't want to get too mathematical on you here, but you should know that when I say additive, I mean, okay, this gene confers a risk, and there's a second gene that confers a risk, and they're independent of each other. So if you have two genes that confer a risk, maybe the risk is doubled. As opposed to multiplicating this gene, and you have a tenfold risk. Okay, so that's multiplicative. Genetics plus environment doesn't explain all of it either. You have genetics plus environment, and then you have the G by E, which is the multiplicative. Most of the incidence of autism is due to our species' inability to cope with the toxins in the environment because those toxins influence how our genes and our proteins work. That's all that means, but it gives you something to hang on to, the G by E. Go ahead, next slide. The other idea I want to share with you and teach you about is this concept of phenomimicry. Glutamate receptors are very important in the brain. Okay, you have astrocytes. They're cells that mop up all the glutamate, right? If you get a brain injury, you get the cytokine release, and you get excess. You get a glutamate signature that tells the microglia, these are cells that munch and clean up all of the debris, the cellular debris, the proteins, and the damaged cells get killed by microglia. They're like white blood cells in the brain, but they have to shut down. And the glutamate signature can stay high artificially. And if you have a mutation in the glutamate receptor, it's not on the astroglial cell, and that astroglial is like a vacuum for glutamate. Just imagine it as a vacuum hose with something stuck in it because your receptor's not working. You can't clear the glutamate out of the brain. Your microglia are going to stay activated. And what they found is when you have a traumatic brain injury, if you can shut down the microglial, right, and get rid of the glutamate, the brain injury is less severe. Same with stroke. Not controversial for traumatic brain injury and same for stroke. You never hear anybody seriously talking about glutamate and shutting down microglial from the CDC. So phenomimicry is where you have a mutation that can cause something, a phenotype or a characteristic, such as excess glutamate in the brain because the receptor is broken. But you can also have an environmental injury to that receptor. It will have the exact same effect on the phenotype. So there's really no point in arguing in a general way it's genetics or it's not genetics, because looking at any individual child, you're just arm waving and you're not really saying anything. You have to sequence the child, look at the mutations, you have to look at their exposure history and actually be an empirical scientist. So go ahead, next slide. So that's the glutamate example I just gave you. Go ahead, next slide. we know mechanisms. I'm going to go into mechanisms now for autism. When you hear about mechanisms, I told you that the IOM found the studies that were flawed and so on. Well, the IOM also decided that they didn't have time to look at all the causal literature. There's a participant there named Barbara McCormick. This was, I think, in 2004. And the minutes were required by SafeMind. SafeMind published these minutes. They had to do a Freedom of Information Act with the meetings of the minutes. And someone said, shouldn't we look at all this causal science and this mechanistic science about how autism could be caused? And she said, I don't have a free weekend to look at it, do you? They ignored the science. When I read that, that really motivated me, because that means there's a big hole in your pediatrician's head, right? There's a huge hole, a vast hole of ignorance that's there because the CDC did not tell them all the balance of the science. I just dove right into the science. I read over 2,000 articles on autism. I took it as a geneticist. Tell me about this disease, autism, this condition, autism. Tell me what the environmental factors might be in the genetics. And that's, I wrote a book on it. You can see it at the end. Excess intracellular calcium can be caused by thimerosal. Listen to me, you never hear this from a scientist. Can be caused by thimerosal. I'm not going to hold back, it's right there. But guess what? It can also cause mitochondrial dysfunction and oxidative stress. All of these things are things that are not supposed to be happening in the brain, and we see them in autistic brain, and we see them in animals when you give them thimerosal. You see them in humans that have had thimerosal. Next slide. Viral infections. Now this is fun. I go to resale shops all the time because it's fun, right? And I'm looking for old medical books, right? Long time ago, 1940s, I found a medical book that said people who have a large number of viral infections might be at risk of autism. Okay? So here we have another study, 1979. If you have multiple exposures to viral infections, this organism that's going to make you sick because its proteins might match human proteins and cause autoimmunity. It has a pathogenicity and so on. Okay, if we knew in 1979 that multiple exposures to viruses, childhood disease viruses, may be associated with autism, and then we package them up and put them in a vial, and then add aluminum adjuvant on top of it, what do we expect? That they're just not going to cause autism now? Okay, next slide. Now, this is a really cool slide because I didn't know this before I went into this, and I made the slide just for you guys. But the genetic by environmental interaction can actually be pinpointed from a specific toxin to a specific gene with a mutation. That's outstanding when it comes to molecular medicine. That means that we can potentially identify which families need to avoid, like religiously avoid organophosphates, avoid pregnancy-related stress, avoid traffic-related particulate matter. If you have a mutation in the MET gene and you're living next to a highway and there's all this dust, it'd be nice to know you should probably move or super filter your air in your home or something. Next slide. This is a short list of the candidate genes that contribute in one way, shape, or form to autism. It's a huge number, okay? So does this mean that it's genetic? We can all just go home and stop talking about fraud and talking about science. It's just genetic. Your parents did it to you. No, let's clean this up. Next slide. Remember I was talking about additivity of genes? So this is a really good study. I wanted this figure in the back of my book. They gave me permission to use it, but we're not going to put it on the back of the book. What these figures show, and this was independent of how they analyzed the data. It's very robust to what model they used. On the bottom axis, you have the number of genes where you have a mutation that is a loss of function, and the y-axis is the relative risk of autism. If you have one hit, you have a low risk. If you have two hits, you have a low risk. If you have three hits, you have a higher risk. If you have four hits, and that's that linear increase of those dots. That looks like, oh, it's all genetic, right? Don't let anybody point to this and say it's all genetic, because this only explains about 2% of autism. The multiple hits in genes are very rare because a single hit in a gene is extremely rare, okay? Getting a second hit in another gene that is a true autism risk gene is really rare. The probabilities multiply. When you take a number less than 1, like 0.001, and multiply it by another small number, the probability gets smaller and smaller and smaller. So although that line is increasing, the proportion of people that have that risk goes way down. Okay? Next slide. Now, here's a list of autism-related traits and genes that have been found to have mutations that are associated with those traits in humans. Okay, that's going to be of interest to a lot of people who have exome sequencing of their kids to find out how to handle, what's going on with their kids. Different genes contribute to different autistic traits. There's not a single autism gene, right? So let me ask you a question. How many of you think that because there are genes that contribute to a risk of cancer, that carcinogens are off the hook? Right? I mean, it's a non sequitur. It doesn't make sense to say, just because my family has a BRCA1 mutation in it, higher risk. Does that mean that any carcinogen that might also increase the risk of cancer is off the hook for cause? No, that's not how the universe works. Next slide. So if you look at the actual sources of variation as well, this will be of interest. The de novo mutations, they're the ones that came in the paraparental generation, the sperm and the gamete formation in moms and dads who have autistic kids or who have any kids. We all have de novo genetic variation, okay? But it's increased in autistics compared to neurotypicals. So it's like brand new mutations. Environmental. Brand new mutation. Environmental. If there's a higher rate of mutations in this group of people than that group of people and they're brand new mutations, something's going on in the environment. Now the polymorphisms are more than 3%. There's a huge number of genes that contribute to autism, so to speak, and autism risk. Not a single gene is responsible for more than 1% of cases of autism. So it's all over the place. There's multiple different pathways. It's very complex. The most complex thing I could ever imagine. But I'll tell you something that you might not know about polymorphism. They're old. They've been around forever. It takes a long time for polymorphism that's even at 4% to be removed from the population by chance. Just by chance, let alone selection or something like that. Because these polymorphisms have been around forever, they're common. And because they're common, we're all walking around with autism risk genes. That means that we're all potentially at risk, all of our progeny are at risk. Next. Okay. I took it one step further. I'm a splitter, okay? So I looked at all the literature on autism genes and genetics, and I split them into 3 categories. There are genes that contribute directly to autism risk. I would be scared to know if anyone had a gene for loss of function mutation in the synaptic protein, in a voltage-gated calcium ion channel protein, and a glutamate receptor. That person's almost 100% sure to have autism. That's my assessment. But they're really rare. Why are they rare? Why are they rare? They're rare because those individuals tend not to have high survivability and high fecundity. Okay? The environmental susceptibility genes, that's the second category. So there's the G by E again, right? A lot of these genes that we know are associated with autism are actually just making us susceptible to toxins. So is the finger going to be pointed at the environment? Or is it going to be pointed at the genes? I think the finger should be pointed at the environment. And then we have some genes, I didn't include any here, but we have some genes that just modify your phenotype, or the way you look, or the way you act, or behavior, or language, intellect, for instance, whether you have autism or not. And so because they're not contributing to it, but they might be more exaggerated in autistic people, we think that they're associated with autism because we looked at autistics for those mutations. I need to go back one slide. I want to talk about ERAP1. If you want to walk away with one gene to talk about, one conclusion from my slide is that thimerosal needs to be removed right now from all vaccines. Because there's a study that came out this year that showed ERAP1 is shut down by thimerosal. ERAP1 is a gene that makes sure that all the proteins that your cells make, including the brain cells, are truncated appropriately during during expression. And if people with mutations in ERAP1 have difficulties with their immune system, people with mutations in ERAP1 have difficulty and a higher risk of autism, people with ERAP1 damage from a thimerosal have a higher risk of autism because their immune system proteins are truncated incorrectly. It's a poison. And there's the mechanism. ERAP1, write it down, look it up. Thimerosal is a poison, not a toxin, it's a poison. Next one. There are some, you'll hear people say that no one knows what causes autism. It's a mystery. But yet, ask any doctor, should I take thalidomide? Well, almost any doctor, any doctor over the age of 40 probably. Should we use thalidomide? They'll say no. Well, why not? Well, because you have, it's a mutagen and so on. And you ask that doctor, are those kids autistic? Oh yeah, they're autistic. So thalidomide causes autism in everyone. It's not a problem. Valproic acid causes autism. We know the mechanisms by which autism are induced by these things. And so that shows that environmental autism all by itself without any genetic component does exist. Another example of that is Minimatis disease. Minimatis disease is where you're getting chronic exposure to high levels of mercury. What happens there is you stop speaking, you get a blank stare in your face, and you start doing repetitive motions. And you're a 60-year-old man. And you never did anything of that before. That's autism. Minimatis disease is adult age-onset autism. So the specific mechanisms of thalidomide are known as reductions in, number of neurons in the, I won't get into the science of it, the facial nucleus. It's important for hearing. Next slide. Now, here's a list of examples of environmental liability. These are studies that are cited. If you have an increase in mercury or amalgam exposure, higher risk of autism. Increased maternal immune activation during pregnancy, increased risk of autism. Increased use of acetaminophen or Tylenol after MMR, autism. Increased autobodies, if you find increased autobodies in the folate receptor, well, where do those autoantibodies come from? Okay, you have an increased risk of autism, and that's an example of molecular mimicry. Aluminum, increased risk of autism, and there's if you have a decreased availability of serum vitamin D3. I have a question for Marcy. Here, Marcy, raise your hand. Great. So after Dr. Poland, right, came out and said, hey, maybe African Americans should only have half the dose of the rubella. Did they change clinical practice?
Nope.
No change in clinical practice, and they know what's going on. This is the level of care and consideration that they give to the population that they're vaccinating. Next slide. We live in our environment. You think about the water, you think about the food, right? Do you think about the medicine as environmental? Because it certainly is. And our immunological environment is also important. Any given protein in your body is at risk of being attacked by other parts of your body in autoimmunity, right? And so, one thing that one study showed, 71% of kids that had aggressive autism, they had an episode of a fever of over 101 degrees just prior. 33% of those had it right after vaccination. Okay? And children with more severe autism had higher amounts of circulating anti-brain antibodies, and moms of kids with autism have a higher rate of anti-brain antibodies in their blood. Where does that come from? One of the stupidest things that we can do to pregnant women is activate their immune system. Half of the proteins in every fetus came from the dad. Those are now maternal proteins. You put an aluminum adjuvant in there, and you're activating the immune system. Maybe she gets a little fever from the vaccine. You're going to the immune system doesn't go, oh, well, see, I'm gonna just reserve my reaction to these proteins that came in the vial with it. I see that. No, it doesn't. It looks around and says, what the heck is going on? I have an infection or broken cells, and I have to get to work cleaning things up. And it finds the dad's brain proteins in the baby. That's not good, right? People say I don't tell people to vaccinate. I tell pregnant women, don't vaccinate. Don't do it to your baby. There's no reason for it, okay? On the next slide. Huge number of studies point to aluminum, okay? Dr. Paul Offit is infamously known for putting on his website that aluminum is not a neurotoxin. In fact, it's good for the fetus. And the reason why we know it's good for the fetus is because premature babies have higher amounts of aluminum than full-term babies, without ever once considering that the reason why they might be premature is because of the high aluminum. So, I have at my blog, jameslyonsweiler.com, and in the book, Genetic Environmental Causes of Autism, a section called Paging Dr. Offit. Your reading assignments in aluminum neurotoxicity are ready. There's a huge literature on aluminum neurotoxicity. Many of them before his book where he said everything was cool with aluminum, and many after his book. If you actually pay attention to the rest of the science that the CDC is not involved in, good science has gone forward independent of them, in spite of them, regardless of them. Next slide. Aluminum also increases mortality of neonates, and it's very sad if you look at rates of mortality. Next slide. And other semi-metals. This is a lot of chemistry, but if you hear somebody say aluminum is not a neurotoxin, right? You can say, well, actually, there's multiple forms of aluminum. There's aluminum sulfate, and there's aluminum salts, and there's other forms of aluminum, and the specific form of aluminum has different neurotoxic effects and in different tissues throughout the body. We know a hell of a lot more about the neurotoxicity of aluminum than these grand flag waving things saying aluminum is not a neurotoxin. Next slide. And this is aluminum persists in organs for years. It's not excreted from the body, it sticks around, and yet every vaccine has aluminum in it. You go on your makeup day, you get 5-7 vaccines at a time, there's a dose of aluminum in every vial. Why don't they have a vial of aluminum adjuvant and then a vial of antigen? They need to make these kind of clinical changes as they're going to vaccinate. About 10% of all aluminum makes it into your bloodstream, whether you eat it, which is about 0.002%, or 0.003%, sorry. Or injected, which is 100%, okay? Accumulates in the brain, it stays there for decades. Next slide. More citations of G by E, I won't go into that. This is one I really wanted to get into. To talk about what causes autism, how the environment might cause autism. You have mercury or thimerosal, you have aluminum in a vaccine. They get picked up preferentially by the white blood cells. Those white blood cells, right, then make it into the brain. When they get into the brain, then they interfere with proper they cause microglial activation. And then you end up with interference of the glutamate receptor ability of the astrocytes to clean up glutamate. And then you get this positive feedback loop, and that's called neuroexcitotoxicity, or excitotoxicity, or immunoneuroexcitotoxicity. Some of you will know about that from Russell Blaylock. That excitotoxicity, basically, you got these microglial cells, and think about them as white blood cells. They're eating neurons, they are eating dendrites, they're eating neural precursor cells that are not damaged. That's a sustained condition in autism throughout life. You can shut that down environmentally. There are compounds and drugs that are available right now, FDA approved, that will shut down microglial activation. They're doing it now for stroke victims. They're doing it now for traumatic brain injury. Nobody's talking about doing it in autism. Next slide. More G by E there, if you're interested. Go ahead, next slide. My conclusion is, I'll tell you, autism by far is primarily environmental disorder, right? All of the signatures and signs are pointing at the environment. And here's how you should say it. The two largest studies that were done looking at the inheritance patterns in autism show that it is at least, at most 50% genetic and at least 50% environmental. Next slide. We know specific mechanisms from thimerosal disruption, BRAF1, intracellular calcium. We know causes of mitochondrial dysfunction and immunoneuroexcitotoxicity. Aluminum is important in both of those. Next slide. These are three worldviews. I don't have time to go into them, but essentially, if you have an increasing number of mutations in an increasingly toxic environment, we're going to end up in a poisoned future where all of us are increasingly susceptible to any toxin in our environment. We have to stop the either or. Next slide. We need carefully developed biomarkers that will predict which children are at most risk for specific vaccines and for seizures and encephalopathy and death from vaccines. This science has not been done because the CDC said stop looking at it. IOM said stop looking at it. CDC said vaccines don't cause autism. We know how to do biomarker development. We know how to discover the biomarkers, and I showed you a list of dozens and dozens of genes that can be useful. The way I look at it is, we can provide a medical lifeboat where the weakest, the environmentally most fragile among us can be identified with biomarkers and give them medical exemption for vaccines and save them from it, reduce the rates of injuries. Next slide. There's a whole litany of potential biomarkers we already know. Next slide. And phase biomarker development is an objective way to do science. It's reproducible. If it doesn't work and you can't predict, you know it. It's not one of these association studies where you just find an association or you don't. The weakest kind of study. Next slide. And that's a picture of the cover of my book. It's coming out in November. A lot of people are telling me that they're not just going to buy a copy for themselves, but to buy a copy for their pediatrician as well. Thanks for your time, and I want to thank the organizers. I want to thank Irene, and I want to thank everyone involved here. Thank you so much.